that the important developments of digital networks might not be these things that you read in magazines like Wired and that will be hyped up as the future thing and so on. Maybe it can be very important to notice things that are a bit boring. When digital technologies become integrated into institutional practices and so on. So what we want to do today, I'm going to give a short introduction that I already started. Then we have a couple of themes with a bit of a red thread between it that we will go through, and I will be more like a moderator, and we have some people who want to show something and talk about some things. And you're also welcome to join, of course, as a discussion. And yeah, these are several themes we will go through that we have identified as could be future challenges that we probably need to think about going ahead, but maybe has not been so discussed at the moment. And one of these, to start with, that I already hinted a bit at with this idea of robotics, is that digital technologies and computer technologies not only exist now in computers or mobile phones, but more and more objects that we don't think about as computers is actually computer systems, or have a lot of computer systems in them. For example, an airplane is more or less a computer. Everything is controlled by a computer. We will see an example of that cars today is more or less computers, and there is not so much difference between a steering wheel and a PlayStation controller. You control the computer with it. So one of these developments going ahead is that computer technologies and software is embedded into objects, and this changes everyday objects a lot that we thought we were used to. It means that they will become configurable, that you can change code, you can change an object by changing code, you can update them, you can. It also means that they are monitorable, so these devices would be able to give off data and someone can see what is happening with these objects, and also they are controllable and hackable. So this development has several names. Sometimes it's called Internet of Things, which is one way of looking at it. Sometimes it's there is this concept of smart cities, that in cities cities give off a lot of data all the time, and this is an idea that if you monitor this data and study it, you can see what's going on in the city. And this brings up several issues. If we live in a society that generates a lot of data all the time, who is this data for? Who is able to look at the data and analyze the data? The people who generate the data, which is often us as individuals and citizens and so on, are we passive or active in generating this data? And in this discourse of smart cities, there is a bit worrying discussion going on, where the view of a city or of the society is where individuals are basically data nodes going around generating lots of data, and then all this data is aggregated by some data analyst or data managers that then use this data to improve government services or improve what they do based on analyzing this data. And this is a very one-way view of all this data, that people generate data and then someone is analyzing it and changing something. We can think about how would this be able to be reversed? For example, that those in power generate data that citizens and people are able to look at and then determine how to respond to this. Can we imagine other kind of data relations where we share data horizontally instead and communicate instead of just generating data for someone else to look at? And this is also a bit, a lot of these discussions are based on that digital data is meant to create efficiency, more efficient things. If you have more data, you can do things more efficient. But is this the ultimate purpose of society, to be efficient, or is it to have new social relations, or what is the purpose of society? This brings up the question of how do we put together the digital technologies in a society, who communicates with who generates data for whom, how do we relate to each other and our technologies and devices. And there are many traps with this use of data, trying to analyze more data to become more efficient or provide better things. One problem that you often see is what you call local optimization. That is, you try to improve something, but have a very narrow view, and by improving something, you end up making the big picture worse. So there is, we can example see, there is a lot of attempts to use data to improve car traffic, to get rid of traffic jams and things like that. You can, if you have data of all the cars in real time, you can plan differently and you can avoid traffic jams and so on. And this is good. Okay, you improve the traffic flow, maybe you improve pollution, because it's a traffic jam creates a lot of pollution and so on. In the small scale, you might improve this. But if you look in the bigger scale, improving traffic might make more people choose to go with car instead of public transportation. And if you have a very good traffic flow, you might start building a city that is based on transportation by car. So you might put important services or resources far out in the city because the traffic flow is so good, so you can go all the way with the car without problem. So you might end up making the big picture worse by improving like a small thing. And that's a danger of this use of data. But a lot of things we're going to talk about now, or at least where we're going to start, is to talk about security of these new digital technologies and when they get embedded into the world. One of the most famous examples of when a computer code has generated a sort of physical problem is, I don't know how many heard of Stuxnet. How many here know what Stuxnet was? You know some. Well, Stuxnet was actually I have a little film that introduces it. I can show this video here. Stuxnet was a it ended up here. It was a computer virus that was discovered in a lot of computers all over the world, and it seemed that the target of Stuxnet was to target nuclear power plants. By going into nuclear power plants and messing with the controllers of it, it could jeopardize the security of nuclear power plants or create disturbances. and especially it was targeted to Iranian nuclear facilities of a special kind. And we can just, I think this film explains it a little bit. The sound is not so important.
In June last year, a computer virus called Stuxnet was discovered lurking in the databanks of power plants, traffic control systems and factories around the world. 20 times more complex than any previous virus code, it had an array of capabilities. Among them, the ability to turn up the pressure inside nuclear reactors or switch off oil pipelines, and Stuxnet could tell the system operators everything was normal. Unlike most viruses, Stuxnet doesn't carry the usual forged security clearance that helps viruses burrow into systems. It actually had a real clearance, stolen from one of the most reputable computer technology companies in the world. It exploited security gaps that system creators are unaware of. These holes are known as 0 days, and the most successful viruses exploit them. The details of a 0 day can be sold on the black market for $100,000. Stuxnet took advantage of 20 0 days. But once it got into a system, it didn't always activate. Buried deep in the Stuxnet code was a specific target. Without that target, the virus remained dormant. What was it looking to shut down? The centrifuges that spin nuclear material at Iran's enrichment facilities.
Okay, this is a bit sensationalist.
Stuxnet was a weapon. The
first was that by writing code you could go into sort of critical systems and disturb them. And it was suspected and almost admitted that the US and Israel was behind this virus. But there are also more sort of mundane. This is kind of on the big level of, you know, international politics and conflicts. We have a more mundane example from Sweden. Actually, this was I don't know the date exactly. I think last year there was an attack on the regional train system of the region in southern Sweden, which was this kind of what you call a DDoS attack, which is basically someone making lots of requests to a server until the server kind of stops working. And this happened towards the servers of the regional train company. And that meant that while this was going on, the ticket machines didn't work, the website didn't work, I think there's something more, their phone systems didn't work and the mail didn't work and so on. And people sort of couldn't use the train and buses in this region. And it turned out that the person who did this was like a 16-year-old bored teenager who had just run a script on his computer and so on. So this brings up several issues. First of all, society relies on very important systems that a 16-year-old can disturb quite a lot. The other is that, I mean, if you look at this from sort of a legal point of view, what should happen with this 16-year-old? On the one hand, he just sort of ran a computer program from his computer. He didn't sort of intentionally harm anyone and so on. And on the other hand, by doing this, he caused sort of millions of kroners of damage and sort of a lot of disturbance in the traffic. So if we build society with this kind of very critical systems that are also subject to being able to be hacked, it would be, I mean, it's impossible to stop if a 16-year-old can do this much, sort of. I will just show another example also here of other things that are basically computers, which is cars nowadays. Now, for example, you might know that Google is developing this kind of self-driving cars that you don't even need a driver, and that's a bit into the future. But even now there are examples of. I mean, even now many cars are. When you sort of turn the steering wheel, you're not actually mechanically turning the car, as in there is something going to the wheels and actually turn it. You just tell a computer to turn the wheels. So here is an example. This is an American journalist, and he drives this. I think it's Toyota Prius. Yeah. No, exactly. Yeah. Yeah. Android mobile phone is yeah. Yeah. Sometimes it's good to have the old also, yes. But this is thing, it's so much more efficient. Yeah, this is good. Yeah, but it's so much cheaper to make things in code than to make it mechanical. So if you make more and more things will be made with code because it's very cheap, and you could even change it by just changing the code. So we will see here. I think I can fast forward a little bit. It's just some.
We did all the tests ourselves.
So these are two researchers
we want
that
to
he talks to,
convince you that we can hurt you without
and
hurting
they
you.
have
Okay, perfect. So that's the plan.
will show how they can control his car by.
Yeah. It was like in 308 easy steps. You
So
could get
this
the
is a
dash
test
off.
car they have, but
It's
it's
got a
the same
screwdriver.
model as you can buy.
Here's where
today.
most of the ECUs in the car are.
What's an ECU?
The computer.
But you can see
So, like,
this is
electronic
this
control
is
unit.
computer.
So how many
I mean,
ECUs
this
are
is.
In this one,
You can see how much wires and
upwards
things
of
there are in the car if you actually
35,
open
something
it.
like
So
that, I
it's
think.
really
Wow.
like
like
a
a
whole.
computer
There's
system.
ones for almost every.
And then
different
we can
function.
see here what happens.
I can forge things like.
So he can tell.
If you look
I mean,
how much
obviously
gasoline we have
change
right
the
now,
speed
see that we
meter
have a
or
quarter of a tank.
Yeah.
how much
I can pretend
The-
that we
the
have a
meter
little
of
tank, and that
gasoline
even works.
says.
You know, while you're driving, I can tell you're going
Yeah.
199 miles per hour.
And then
now,
when he
even though
changes the
that's very
speed meter,
apparently
the
not
car
the
has
case.
built-in systems to react to that,
Whoa.
so it
Goes right
stops
from-
automatically and so on. So
Yeah. So you turn the car off and on.
Okay.
So we just tricked the pre-collision system into thinking
So all
something
of
very
things
odd
are
was happening, right?
activated
'Cause I was telling the
automatically
car
by
we're
the
going
car.
199, and it was like, should I brake? Should I
I
tighten the
see.
seatbelts? What should I do?
It went from like 201 mile an hour. It's like I,
So
think
the-
I just ran into a brick wall.
Yeah, exactly. I ran into
Yeah.
a brick wall at that speed.
So now he can
Miles per
control
hour
the
is, like,
steering wheel
yeah,
also.
Totally off.
So all of this is
Oh,
is just
Control. Can you make it go left now?
computers.
So if you can like completely stop. So again, if you're going.
Yeah, yeah. All of
If
these
you're going 80
security
in
systems for
traffic
the
in
car
this, right, this is
braking
going to be.
and so on.
What I'm doing here
that's why you need,
is I flooded the
computers.
CAN network
But it
with
also
traffic
means
with the
they can
speed it
be
didn't know about, and that's why the
controlled.
speedometer read 0. And then I told the car it was in reverse and it was trying to park itself,
Oh.
and therefore it was doing the very heavy jerky motions. If you would have stopped the car completely, you would have seen the wheel do 2 complete rotations in a clockwise direction. This is one of the funnest and most annoying ones.
And this is just
Oh my
a
god.
few examples.
What happens if I can't do anything?
Another.
Are you guys both buckled up?
Okay, wait, Another example is energy, for example. In many new homes, you now have these smart energy meters that you install, which is like a digital little device that measure your energy. And this means that you can see how much energy you have used with very fine precision. But this also means that if someone gets a hold of this data, they can tell a lot about you just by looking at the energy use. They can see when you're home because the energy use is up. They can see when you're away because there is flat energy and so on. And yeah, sorry. Yeah. So, for example, in the US, these have already been used by the police to catch people who grow marijuana in their home, because you can see how the level of their energy. It's kind of easy to.
How much energy is being drained?
Yeah. Oops.
It's a big difference by having to look at each individual apartment, or just write one line of code and you will get all apartments that use too much energy.
And these have also been hacked. There was a demonstration at the hacker conference in Germany where they showed that they can hack this and actually change the levels also. So you could either change your own so it looks like you don't use any energy and you don't get a bill, or you can change someone else's and make them look like they use like they're growing marijuana, basically your neighbor. Anyway. So the thing is also that a lot of these systems are rolled out without much testing, because it's one company that delivers them and another company buys them and installs them. Internet technologies is open for anyone to kind of test and see if they are secure or not, but it's often hard to know with these systems because it's closed systems. And this brings us further to the sort of general security of internet systems going forward. And I don't know how many heard about something called the heartbleed bug. One person. It's been quite a lot in the news lately. There was this bug, we will explain it a bit more, but there was a bug in a very common protocol for doing cryptographic transfers. So anytime you log in on a web servers, your web email, your bank and so on, it's encrypted traffic, so no one can see your password and so on. So recently it was made public that for 2 years there had been a vulnerability in this encryption. So anyone knowing about this could go in and get sort of passwords and other data. And like this was affecting, you know, Facebook and Google and all of these big ones also. So you should change all your passwords on the internet, basically. And we're going to show a bit, maybe you want to explain it a bit and then we show it, or explain while you show it. And yeah, or use this one.
Okay. Okay, so the reason why we want to show you how this bug is working in practice is because it affects almost all the common websites on internet. In fact, all the websites that use HTTPS is affected. And I don't know if you have read the text yet, but in short, the bug is performed by sending a very small packet to the server, asking for a certain website to be displayed and asking for establishing a secure connection instead of a normal HTTP connection. But that small transport layer in between unsecure connection, HTTP, and making an HTTPS request requires some negotiating between the client and the server to exchange and get a so-called session key they can use for secure communication. And about 2 years ago, a new feature was introduced into this transport layer called SSL, which stands for Socket Security Layer. And that feature was supposed to allow the developer of a program that uses SSL to define something called a payload that was sent along with the packet to the server. And that payload can contain anything and is supposed to be used to identify the service you want to get at, or who you are, or something else that can be unique for your communication. But this had not been quite as tested that it should have been. Just like Magnus said before, and it contains a small bug which can be exploited by simply sending a large enough packet. So the software that checks the contents of the package gets confused and returns content from its own memory instead, which means you can craft this custom package yourself and therefore determine what content you want to get back from the memory, which means that everything that's inside the web service memory at the moment that you make the request you are able to read in plain text, which essentially means that all the login sessions and all the accounts and all other cookies that are related to identification are readable in plain text by the attacker. For a couple of days ago, someone posted a huge list of domain names that were gotten from Alexa.com. That some of you might know is a service that ranks websites based on popularity and categorize. And we went through some of these sites and found that many of them still are vulnerable. We checked this morning, and as much as 100 of them we tested are still vulnerable for this exploit. So we chose a site at random, which turned out to be a Russian service for transcribers and translators that they logged into and send their texts to software companies that they work for on commission. So I was gonna take over the computer here and show how easy it is to get the login credentials from that site without having access to it.
Do you want the shell here? So this was just a demonstration with using our own login, but this heartbleed bleed bug meant that for 2 years this was possible to do on most of the large sites on the internet. Government sites, Facebook, Gmail, and so on. So
yeah, it includes
banks and everything.
Accounts and everything that uses HTTPS was vulnerable for 2 years without anyone, without the public knowing it, at least.
So even at the heart of the internet, there is very insecure, or could be very, very insecure technologies. So we rely a lot on this. So that's why, again, change your passwords on these sites. Actually, this is a screenshot from the site heartbleed.com. I think there is a list there of like sites to that was affected by this, but it's almost all the sites. So
I think it was 60% of the world's servers.
Oh, okay.
For 2 years without anyone really auditing it or making an effort to fix it.
Really a very naive question. Is it at all possible to trace back who entered without?
Yeah, you will see the IP address from the connecting. You will see the IP address from the connecting user at the server, but it's very much easier to fake an IP address than to come over an exploit like this. Just go to a library or go to Starbucks or.
But this is it's a good question, because if someone usually hacks a system, in the sense to get access to a server and go in and do stuff there is logs of what they have done. You can see this person logged in, they went here, they took this information. Here you're never in the actual server. You trick the server to give it out, sort of. So
Everything you have going on right now.
So that's why people have been saying, we don't know if the NSA or someone have known about this for 2 years and have all the passwords in the world already. You can't see that if they have done this or not, basically. So
You can see on the packet that this is behaving differently than another one, legitimate user trying to make a secure connection.
so that's what made it so. And also, it's not. I mean, it was a bug in just the design of this protocol. So it's no one has deliberately put this weakness in there. Sort of. It was just no one had discovered that there was a weakness when they designed it. No one thought about.
Good idea at first, but
One programmer made a mistake.
Yeah.
Big mistake. Yeah, huge.
and one of the biggest implications of a bug like this that Yeah, well, one of the biggest implications for a bug like this that doesn't actually enter the server and doesn't actually limit your access to anything is that if the server has any passwords of its own that it has stored, for example, database connections or making connections to other HTTP server in the background, you could get those secrets, although those were not ever available on the actual website. But they were only available in the memory of the server, but you can still get them through this exploit. Most common exploits utilize bugs in databases or in the file system, which makes it possible for you to read files or read database contents. But this actually even allowed you to read private keys and password that only the server or a local user on the server knows about.
Yes. So yeah, a lot of people when this came out was sort of had a nervous breakdown. Well, it's because all of a sudden all of the internet had been open for 2 years for anyone. So. Yeah, that's yesterday's news. Yeah. We wanted to continue a bit to talk about kind of how we rely on these cloud services and because nowadays most people are not sort of running their own internet servers or web servers or even software. Most people use external services and sort of fewer and fewer host their own email or have their own email software even and use webmail and so on. Jonathan, did you have do you want to introduce the cloud topic a bit? You need a microphone. Yeah. Oh, jag får nog starta om det.
So, regarding cloud services, is everyone familiar with the expression the cloud service? Basically what I refer to is very large internet services that have, as infrastructure, become their own internet operators. So, take for example Facebook or Google or Netflix or any of these big operators. They are called cloud operators. Because you have a computer cloud all over the world that manages the same service. And there are other types of cloud services that, but I was talking about the ones that you see and use yourself. So Facebook and Google are the biggest examples. These types of services are by now not new. I mean, I don't remember which year either started, but I mean they are nearing 10 years old, I suppose, both of them. But they have changed the internet in a quite big way, and of course, in the obvious ways, very positive ways. I mean, we have gotten so many new ways to talk to each other, new ways of finding information. I mean, the internet was, I think most people can agree, much less usable before Google. So they've provided lots of new services that are great and helpful, and they do so for profit to show ads and make money, but that's not a problem. I mean, they give us good service and everyone's happy. But they do prove to be challenges for internet that was earlier a very, as Magnus described earlier, a very open network. While these are, to a very large extent, closed networks. And this problem is not, or these challenges are not new. They have been around for many years. The one that I wanted to introduce today and start to discuss is one that is just now emerging, which is that a few of these operators are starting to, with a focus on emerging markets, so countries that have very little internet usage, have started introducing, they go to the mobile operator saying, hey, we want our product service to your subscribers, your mobile phone users, for free. So basically, for example, the first one was Facebook that introduced Facebook Zero. And that was introduced 2010. I think it was like 30 countries or so. Countries that have, I mean, many countries in Asia and Africa, I think it was a focus especially on Africa, where anyone with a mobile phone suddenly could use Facebook in a limited way for free, zero charge. That's where the zero comes from. And this is of course great. I mean, they get access to internet which they couldn't afford. But they don't get access to internet, they get access to Facebook, period. And Google has done the same, introducing Google Free Zone, which means that the users of in those countries get access to Google, but not internet. And for those users, this becomes the whole internet. When they get introduced to internet, and they are new users, what they will know is Facebook or Google, period. They will not have the same experience that we have when visiting Facebook. I mean, if you're uncomfortable or don't like the service or want something else besides it, you can use both. Or you can start using Twitter, or you can get an email provider somewhere else. You can go anywhere. I mean, that's the openness of internet. They get a service which is visiting Facebook, and of course they will start. Also, as Magnus described in the introduction, they will start using Facebook as if this was the whole internet. I mean, it's not. You can't say it's wrong of them to do this, but this provides a new challenge, and this gives this portal experience that we got in the early days of internet when you had dial-up modems. When we have the European example of Minitel, which was early days of internet, and in Sweden we had Passagen, which was also a attempt at making a portal internet, which means that you connected to the internet, but you just got one site, and that site was supposed to provide everything that was supposed to be internet. I mean, very, very early on, during the 1990s, we realized that, I mean, we can get so much more, and these portals sort of collapsed on themselves. The biggest example, I guess, is AOL, America Online, that was in the United States. But this service is now emerging again. The same model is emerging again. And that's something that's, I think, worth analyzing and looking closer upon, because that is a emerging new way of these cloud operators to work, and they are doing it with no wrongdoing. I mean, they have no wrong reasons of doing it, but it provides new challenges and possibly new problems. Although, did you want to go more into cloud operators?
Well, we can just say that, I mean, to see the difference here, really, if we, and this is also what was so unique with the internet, that, I mean, with the way we imagine the internet is that you as a user connect to an internet service provider, but then you are the ones who determine what other computers connected to the internet you want to connect to. If you want to go to Facebook or Google, or if someone I know has put up a server on the other side of the world, I can just ask to go there. And the role of the internet service provider is just to get the traffic from that site to me. And this is, if you compare to other sort of infrastructure systems, this is not the case. Well, it starts to be in some, but for example, electricity is usually that electricity, for most of us, we think of it just as something we get as a service. We pay for electricity and we get it to us. There is no plug here where I can plug in a device and send electricity to someone else. That is coming a bit. But the internet is quite unique, that the internet has not been that you connect to an operator who is the one who gives you what's on the internet. The internet has just been made up of everyone who connects to the internet in the ends, and the ones in the middle only shift the traffic to different people. Anyone can set up a web server and so on, and more or less on equal terms. But this would mean that, okay, Facebook gives you this for free, but you connect to Facebook and you say, I want to go to this server, and then Facebook will say, no, they're not part of our our partners or something. So we're not going to let you go there. You have to pay to go to that server. You can only go to this servers that we provide and that we have. So they end up deciding what you can have access to or not. And maybe also another point, like you say, they do this very good. Google provides a very good search engine and so on. And probably using this will be very fast, very convenient, and very secure. But you still don't have the freedom to connect to something that they have not decided that you can connect to or not.
Yeah, so you can describe this, I mean, as the example of the electricity company is that you have a producer, you have a power plant, and you have consumers, houses and people needing electricity. And the internet has always been that each and everyone connecting to the internet is both a producer and a consumer. You can choose just to consume, just visiting Facebook and it's fine. But your computer could just as well, with a few clicks, become a server on the internet, and anyone else could visit it. So, I mean, even if you seldom exploit this possibility, the internet has always been the possibility of becoming a producer. And that is the possibility that goes away when, I mean, what this essentially affects is what's commonly referred to as net neutrality. I mean, the network is no longer neutral when the whole of internet is replaced by Facebook. And you could also see that for a new user that just gets its first internet access, and which is through Facebook Zero, for example, or through Google Free Zone, they will, of course, try to do everything that we try to do over internet. They will see, can I get access to my bank? And maybe Facebook in that country will have an agreement with one of the banks. So then they will see, I can do mobile banking if I have that bank, but not if I have that bank, because just one of them has paid Facebook. And then you get a non-neutral network, which becomes a service network of sorts, which is much more closer related to what a cable company provides for cable TV. So that is the fear where you could land if you don't have, if so many new users. I mean, they're talking about, like, there are a few billion users that have mobile phones that don't have internet. That are just, I mean, nearing emerging and getting internet access. And if even half of those get one of these services first, then they will be larger than internet. I mean, the internet that we know will be a minority of the users. The rest will be using a customized service with access, which is, I mean, controlled by commercial interests. And then we get something completely new, which, of course, where I stand is something lesser and something that we thought we came away from during the late 90s. We thought, I mean, okay, so this is the first way we did it, then we could do it better, and then we were happy. We had it better for 15 years. And now we risk going backwards again. Yeah.
That was depressing.
Yes.
Yeah, please. Yeah, I mean, I guess this. Yeah, repeat it in the microphone. Just.
What would be possible solutions or possible strategies to be able to counteract this development?
I think it's a little bit different depending on where you are. As Jonathan said, where Facebook is trying to do this is mostly in countries and regions where you have a lot of mobile phone penetration, but no internet. So no 3G and no fiber cables, no broadband. So the tricky thing is for these people that get this offer from Facebook for free is that either you have no internet access or you have the one that Facebook determines. So for them to get an alternative, you need actual sort of physical deployment of infrastructure, whether that's 3G mobile internet or landlines, fiber cables, sort of. So in these regions, this is the bit tricky thing, that they actually provide something more than nothing, but it's not what we have been considering the internet. For us here who live in countries where we have internet infrastructure, both mobile and fixed, it's a bit different things, because then there is about choice and what makes you choose something and not something else. And that could be this is for free, the other one costs 30-40 euros a month. It could probably also be that this one is faster, more convenient. The other one is a bit difficult to use, maybe sometime. Maybe you just log in with your Facebook ID and you can check your bank account without, any problems. Another thing could be security. Maybe here they can keep viruses out because you are only using their networks. If you use the open internet, you risk getting a virus in your computer, or maybe at least Facebook will tell you hackers will steal your data and they will infiltrate your computer and so on. So scare tactics almost. So my answer would be that it's both a technical and a cultural issue. So technical in the sense of providing an alternative, and cultural also in the sense that what is sort of giving the people the option to choose, the knowledge to choose, making sure these things are valued, internet freedom are valued, so the cost of choosing closed networks is understood versus open networks. So yeah, it's both cultural and technical challenge, I would say.
I'm sorry, I didn't quite understand what you mean by cultural.
Well,
challenge.
cultural is in the sense that it's a technical challenge to provide an option for someone to choose something else. But it's a cultural or we could even say socio-economic issue of making sure people can choose this thing that costs 30 euros instead of the ones that cost 0. For many people, that those 30 euros will be valuable to spend on something else. But also a knowledge issue of understanding what is sort of what you can't get access to through the Facebook network, and also maybe not only thinking about it as an individual choice and individual utility, because even if maybe for someone personally it would be a better and more convenient way of using this, other people are very dependent for whatever, getting independent news out or independent information out, or organizing in different ways, not risking being shut down by Facebook's policies and so on. For those people, it's very valuable and necessary that this open internet is also available, and that people are using it and supporting it. So that would be more of a cultural thing. Like, do I value sort of the democratic aspects of the open internet enough that I support it instead of the convenient solution, sort of, using Facebook. So.
I would.
Yeah. No, please.
No, I would tend to argue that it's a cultural thing.
Yeah.
More, I agree, socioeconomic. If I'm given a choice,
Yeah.
With limited resources, do I choose between something that costs 30 euro or 0 euro? What am I getting for it? Cultural issue, I'm still not so sure that I agree with that. I think even in countries where there is, it's not a problem of technical resources or economic resources, we see also in terms of news, what news do people watch? And when we're talking about, I don't know, CNN, is this really an independent news? What is that controlled by? Although I don't know if there's really so much of a choice, but what is mainstream and what is, I don't know, I have a problem with this, the cultural,
Yeah, but
dimension
yeah,
of
I mean,
cultural or knowledge or aware of values. Do you understand? Do you understand what I'm? I think there's a problem with referring something to something that's cultural or value oriented, perhaps associating that with other countries that don't have certain technologies, because I think the same things happen in countries that have the technological resources, the economic resources, yet often the freedom to choose is not really used.
Yeah, that's what I'm referring to. So.
Do you see a kind of dystopic future where it would be possible that the open internet would be to compare with some kind of Linux hardcore user alternative and Google, Facebook as OS X and Windows for common people?
What do you think?
I don't know.
Yeah, no. I mean, I'm not more informed about that. I guess it's definitely a possibility, but to me, the thing is that just speaking personally, I guess I took the internet very much for granted for a long time. That okay, now we have the internet. It's clearly better than what we had before. Now we need to just use it as best as we can. So it's quite annoying that this feels like being thrown back to the dark ages. Now, but I think personally I have shifted a bit in thinking of taking internet very much for granted to really comparing it to other infrastructural systems or communication systems we have and have had in the past, and see that it's quite a unique thing. Hopefully that it's unique does not mean that it's a historical exception, that people will look back on the golden days or something like this. That would be very unfortunate. But just to understand that we can't take it for granted. And I think the taking for granted followed this kind of modernist narrative of progression. That okay, first there was TV, then there was one producer and consumers, then there was internet, and everyone communicates with each other, and this follows a progress towards sort of something, which I mean it's not how history works. So. Not by itself, sort of.
Just that you mentioned Linux and open systems, I think getting back to my point before, in regions where the technical resources and socioeconomic resources are available, yet people still choose Microsoft and Apple over open systems. And that's getting back to the point where it's not about value systems or absolutely not about cultural
so why do you think
aspects.
people are not choosing Linux?
It has something to do with marketing, but even people with socioeconomic, we talked about open and closed systems, buying something, having the economic resources to buy software, you're buying into a closed system. You're buying into a dead end, basically. And that's the same type of logic, I think, that is being used on the level of internet, either a closed system or how did you refer, non-neutrality system?
Closed,
I don't know.
Not neutral.
System,
yeah.
But the argument is then changed.
Well, my argument was that there is a risk that internet becomes the Linux. The open internet is something used by special communities. It becomes like a subculture of this open wild net, and most people will use the safe, convenient Facebook option, sort of, which is the same way people use Windows and so on.
Is it safe? Is it convenient?
Okay. Maybe not Windows, but well, maybe we can say we can probably learn a lot from how people choose to use operating systems and why, to understand what would make people choose open internet versus closed internet. And I mean, yeah, this probably. I mean, even if we let's say the technical and socioeconomic resources are there, what other factors play in? Is it that you just using the same as everyone else is using, or I mean, what kind of factors are involved in that, and what could shift the balance from one to the other? So. And
education, but also I think yeah, perhaps education, but also not just economic access. I think it's also a matter of, I mean, why do people choose Windows?
Yeah.
Whether they have the economic resources or not. Yeah, and it's perhaps we're talking about corporatism.
Yeah.
The influence that these large companies have.
I'm wondering why I'm wondering why to expect a different behavior in concerning to internet. If you look at the most common behavior in the societies, actually in the actuality, you don't see another. It's the same. It's the same behavior. It's the same tendency. The same tendency. And I don't understand this expectation. That's what I don't, because it is interactive.
No, I would say because.
Or it could be interactive.
Because for whatever a historical coincidence, internet happened to follow a bit of a different trajectory for a little while, at least. A while it might look like this was taken. You could take it for granted. Internet was something completely different than the other logic. Now it doesn't maybe look like that. Now it looks like it managed to go off in a little different, weird way for a little while, and now it's leaning back towards what you're talking about, the same logic. But we have a little bit of a head start. Can we? What can be done to keep internet out there? Is there something, or?
Yeah, but it's the same question you have when we think about print media. And it's the same question if think about literature. What are people reading?
Yeah.
Yeah, and literature and arts, they are also space sectors of society where you can be mainstream, or you can intervene. You can change. You can. I think the question is not specific to internet. That's what I think we have to think. That's why I was talking about education. Education in a very open conception of this. Not talking about school.
Yeah. That's, I think, what I meant with saying culture.
And when you say internet was at the beginning promising something or showing something else, or who were here as actors acting? Maybe it's like when it got more access, more people acting here. Of course, today, we are here. There are people using internet in another way, in a critical way. Yeah. But it's a minority. It's like in other fields of society. No? And the question is what these minorities can do what kind of strategies we can do as minority groups to expand this knowledge and these strategies and so on. I don't know if.
Have you finished the presentation?
Yes, this was a very good comment to sum up everything.
Okay, so
it's good notes to end on.
Thank you so much for your presentation, and that was a really interesting